Hello everyone. So my name is Jason. So this is my thesis topic. On my way, a system for optimizing the driving routes for crowdsourcing application. So first, I want to introduce the problems need to be addressed in this thesis. So let's first think about the situation. A person wants leaving his home to go to his workplace. Before arriving at destination, he want to go to the restaurant to have a breakfast. He want to go to a gas station to put the gas in his cars, and he also want to go to a shoe store because his shoes got ruined last night. So in this situation, several restrictions may be applied before when considering the route recommendation. The restriction could be several intermediate waypoints must be visited before arriving at the destination. But the route recommendation given by the traditional GPS has a lot of limitations. First, the route given by the GPS is only care about two locations, that is start origin and destination. And if a user want to go to a gas station, what he probably do is first search for the gas station around near his location, and then pick up one of them and manually input the address into the GPS system. And several web applications can be used for calculating the multiple waypoints, optimal routes through multiple waypoints. But as a user, need to input the address of waypoints manually, one by one, and the order of the visiting the waypoints is not optimal. It's not optimized. There are several mobile applications can be used for navigation, but they are still only care about the original and the origin and the destination. So on mobile platform, there is no good application to calculate to solve this issue. So especially on the Android platform. So based on the problems, there are lots of key points in order to select the problems. The first is waypoints can be as a selection from a set of possible choices. For example, if you want to go to the restaurant, there could be many places available near you. For example, maybe a Starbucks, maybe a McDonald's. And this place, it will be better if this waypoint is on the way and along the road to the destination, because it will save a lot of time. And the order of the visiting waypoints must be optimized. And as a user, they do not know. As a user, he do not know where, how many stores is near him. So what a user want is just recommending the waypoints to the user. So in this the application in this thesis is designed with just setting the home and work address, and then the user just pick up the several general tabs the user want to go, and our application can recommend the waypoints and also the optimal routes for user. So in this thesis, we propose an algorithm to help search the nearby places. Actually, we use the Google Places API, which will be talked in the following slides. And we also propose a strategy to help get the optimal routes, driving routes through multiple waypoints. And we use a satellite map. We draw the routes on the satellite map and also mark the waypoints on the satellite map. And all of these are based on the Android platform. So before I step to the implementation, several concepts need to be explained. The first is a waypoints combination. The waypoints combination means a set of intermediate waypoints must be visited before arriving at the destination. And the actual driving routes is the routes on the graph. You can see from the home. This is home address. This is work address, and this rows made up of blue and yellow line. This means actual driving routes, and the dark line means bird view distance, which is a distance viewed from bird eyes. So then I want to introduce the algorithms and APIs used in the implementation. We use the Google Places API to search the nearby places by sending the HTTP request, and it will return your JSON object, include all the basis information. And we use the Google Direction API to calculate to get the real-time driving routes, because Google Direction API can automatically return your routes with optimizing the order of the waypoints. And we use the Google Maps API to provide a map view, especially a satellite map view. We use the Crowdsourcing algorithm to calculate the shortest path of waypoints. So I will illustrate the implementation. So first, what we do is search the nearby places. So what we do first is first calling the Google Direction API once to get the optimal routes through the work address to the home address, and then at each corner search our nearby places. So at every corner search the nearby places. So after this search, we could get a lots of possible choices according to user-specified types. For example, if a user wants to go to a gas station, in this circle it may have 3 or 4 of gas station. And after searching nearby places, we can get a set of possible choices. And after removing the duplicate places, those places will be saved in an array list, and based on their general type. For example, if a user wants to go to a gas station and a restaurant and a bank, so at this time, the places which belongs to a gas station will saved in the array list. And another array list is for the places belongs to a restaurant, and then another array list for the places that is belongs to a bank. So after get those array lists, we select each time we select one place from the array list. So after 3 array lists, we can get waypoints combinations. So then we calculate all the waypoints combinations, all the possible waypoints combinations of this start and end point, and connect each waypoints in each waypoints combination with each other, and then we calculate the shortest path of the bird view distance shortest path of the waypoints in each waypoints combination, and based on the bird view distance, and then we sort them in ascending order. Only select the best 3. Select the best 3 waypoints combination with the most 3 shortest paths, and then send those 3 waypoints combination to request the actual driving routes by using the Google Direction API. So at this point, you may have a question: why not directly call Google Direction API? Because in the later experiment showed the average number of the waypoints combination for each start and end point is 105. So calculate direction is a time and resource intensive task. So if we directly calling Google Direction API for all the waypoint combinations, that means running the application once, we need to calling 105 times Google Direction API. If we calling Google Direction API at such high frequency, it may lose data and get no response from the remote server. And also, Google Direction API has a limitation of 2500 requests per day for free. So if we do so, it will cost too much. So this is the user interface design of our application. In the left graph, there is an interface for user to pick up the general tabs. So here, actually, this is the auto-complete text fields for user to pick up the general tabs. If a user selects the general tabs, the tabs will be saved in this drop-down list. And in the right graph, a user can see the optimal routes through multiple waypoints. And by switching the radio button on the top of the screen, the user can check the different route. And the corresponding route information include the route name and the route distance and the route time duration. Driving duration will be displayed on the information board. So this is the navigation path of picking up the general tabs. So when the user first running the application, it will ask the user to keep safety. By click accept, the user can enter the interface to set the home and work address. After that, the user can pick up general tabs, as I said before. And then, if a user clicked the tabs already picked up, it will ask the user whether to delete these tabs, because these tabs will be saved in the local database. So unless be deleted by user, it will always there. It will be always there. And in the second part, a notification will be launched at 9 o'clock and 5 o'clock, because which is the time for user to go work and back home. By clicking the notification, if a user not setting the home address, the screen will ask the user to set the home address again. If not, the user can enter the main screen, and by switching the radio button on the top of the screen, the user can check the different routes. And by clicking the marker on the map, the user can see the name of the place and the order of the visiting that place. So at this point, you may have, as I mentioned before, we use a bird wheel distance. We first calculated the bird wheel distance, and then select the best three to requesting the actual driving routes. But why we can use a bird wheel distance? So we designed an experiment to answer the question. So this is one of them. Basically, we tested our application at 20 different locations from different states in United States. So this is one of them. So in this table, the route number stands for the waypoints for one waypoints combinations, and the BW stands for the bird wheel distance of the waypoints combination. DIS stands for the actual driving routes distance of waypoints combination, and DUR stands for the driving time duration. So we also marked the best three shortest bird wheel distance with red color, and best three shortest actual driving distance with yellow color, and the best three driving time with blue color. So from this table, you can see if we select the best three, if we select the waypoints combination with best three shortest bird wheel distance, we can get at least one of the three best shortest actual driving distance. So let's see the experimental result. So in this graph, x-axis stands for the each root number, as I mentioned for in last table, and the y-axis stands for the distance, and the green points stand for the actual driving roads distance, and the red point represents the birdview distance of each route. So from the graph we can see, with the increasing number of the birdview distance, the actual driving distance is also increasing. That is, the birdview distance is proportional to the actual driving route distance. So in order to further show the result, we use R to plot the waypoints combination in a 3D space. So in this graph, X stands for the birdview distance, and the Y stands for the actual driving distance, and the Z axis stands for the driving time duration. So actually, the point in this circle is what we needed, because by select those points those points has less birdview distance and has less actual driving distance, and also the less actual driving time. So by selecting the waypoints with the less by selecting the points with less birdview distance, we can also get the waypoints combinations with less actual driving distance. So in last table, we can see some waypoints combinations with the same birdview distance, but the driving distance is totally different. So we also designed a JavaScript web application to show what happened after the waypoints combinations. So each graph, the red graph stands for the waypoints combinations, and the left graph is also stands for the waypoints combinations. And the work marker stands for the workplace, and the home marker stands for the home place. And the rest of our three markers, stand for the waypoints must be visited before arriving at destination. So in red graph, this blue roads produce more distance. That is because if we use a Google Direction API to requesting the actual driving roads, it probably gives you a route with less traffic and also the high speed limit. So in the red graph, when we calling the Google Direction API, it will return you a route that is with a light traffic and also a high speed limit. So let's see another result. So in this graph, A stands for the home address and E stands for the work address. So the rest of our three markers stand for the waypoints must be visited before arriving at destination. So in the red graph, in order to go to the waypoints D, the person needs to drive too much road. That is because there is a bridge between E and A, and between E marker and this marker, because there is no directly route through D to this red marker. So one need to drive much road in this situation. So based on the experiment, we can see the average number of waypoints combinations in all tested locations is 105, and the best three birdview distance may not be always the best three actual driving routes, but 18% of the results show at least one of the best three shortest driving routes will be selected using our application, and 90% percent of results shows at least one of the best shortest time duration will be selected by using our application.
Great. Thanks, like the speaker.